Good afternoon, everyone. First, thanks for being here. So today, I'm not going to be talking about AI as a magic wand. So instead, I'll share the strategic approach that we took at eBay by combining platform engineering with machine learning and AI to reduce developer friction, accelerate velocity, and improve software quality. I'm Aravind Kannan. I'm engineering director at the infrastructure organization. I lead delivery engineering and developer productivity groups at eBay. And I also lead a company-wide track called Engineering Velocity. So eBay has about 400 teams, 3,000 plus engineers, and 270 of those teams help deliver user-facing applications. We have about 4,000 plus user-facing applications, and our engineers deliver 1,600 plus commits on a daily basis to production. So if you look at our software delivery, 92% of these changes are continuously deployed with zero manual touch. From the time it's merged all the way to production. 6% of these changes are continuously delivered, so there's a manual approval step. So the time it takes for our build to go to the first box in production is under 40 minutes. And engineering velocity. So the vision for engineering velocity is to empower and enable eBay's engineers to create and sustain high-quality applications fast and with ease. So that's what we're chasing with the whole engineering velocity track across the company. So we have an internal software engineering intelligence platform where we measure hundreds of data points about SDLC. And DORA is also our favorite, like many of you here. And we use DORA as outcome metrics to measure success. And we also measure various developer frictions across the journey of a commit to production. And developer friction metrics is what we use as leading levers to identify pain points and drive improvements. So with this, we are now, if you look at a deployment frequency, it's 10 times more than where we are at 2020. And we are seeing a 20% increase in 2025 compared to 2024. So our lead time for change is 11 hours faster now compared to 2024. And 70% of our applications have a lead time for change of a day or less. And many of these deploy multiple times a day. And our failure rate is about 3%. So developer friction. So this refers to any obstacle a developer may face while they attempt to develop, build, test, and ship the software to production. Why do we care about this? Because high levels of developer friction slows progress, reduces efficiency, velocity, and it impacts our software quality. So if you look at the outer loop, so there's various friction points here. So anything that's slowing down or blocking the attempt to deliver commits unnecessarily is considered to be friction. So the feedback duration, the build duration, the time it takes for a build to be produced from the time the pull request is merged, flaky tests, manual approvals, manual deployments unnecessarily, and also the time it takes to certify a build as deployable to production. Right? All of these things are friction points. So let's go to let's see how we combine AI and ML throughout the platform journey, right? So if you look at the inner loop, like many other organizations, we use AI assistant embedded in the IDEs. So we use Copilot, Klein, Cursor, and things like that. Our developers have access to these. And in addition to that, we also have fine-tuned our models based on the open source models. So it understands eBay's frameworks and patterns better. And using these, our developers are able to generate code, test, generate tests, test data creations, and also not just that, right? It's also helpful in migrations and software upgrades. All of these things are useful use cases for us, and documentation too. Next, if you look at the outer loop, the very first point where AI helps us is PR summarization. So when a pull request is created, so AI kicks in and leaves its summary of the pull request, giving a quick brief of the changes and why certain change was made and what are the files that was affected and how the test looks and things like that. And in addition to that, it also does code review. So our code review agent, which is built internally, it is highly configurable. People can specify if they have to look at maintenance, security issues, bugs, and what type of severities are they interested in, and things like that. And they can also chat with it, how you would chat with a human being reviewer. Next, log analysis for RCA. And then we use machine learning and data science techniques across our software engineering intelligence platform, where all the SDLC metrics are tracked. and it gives us like good insights and recommendations there. So developer support is another area where we use AI. Predictive optimization. So pipelines are continuously scanned, looking for areas for optimization, and our agents are good at like identifying those and like surfacing them in the pipelines. So we also have an agent that does test failure analysis, an RCA for that, so that it goes deeper into the service calls and digs logs and finds the RCA, saves hundreds of developer hours. So pipeline failure RCA is also another area. So we do use like machine learning to identify and perform automatic retrace for pipelines. Like, of course, like we want to avoid the retrace as much as possible, but there are scenarios where it is needed, and we use ML for that. So then, like deployment monitoring, automated rollbacks is another area. So it's post-deployment monitoring as well. Developer feedback analysis. This is another area that we find good use with AI agents. So we collect developer feedback across our platform tools, like we have an internal IDP. And any feedback the developer provides there, we use AI to analyze that, slice it and dice it various data points, and then even like recommends like improvements in the platform. Finally, we are a globally distributed organization. So platform release notes and newsletters, it is important to keep the same tone, style, and structure across, irrespective of where these are built. So we use AI to help us there as well. Now, look, here we are looking at a screen where, this is one of a screen from our software intelligence platform. And here we are looking at an organization's developer friction, and you can see it's trending down. The histograms basically show like how many applications fall in each buckets. And also there's a scatter plot. Each dot that you see there is an application. And when you click on that, application owners like get very targeted recommendations on what could be done to improve velocity. So right here, you see a correlation matrix. This is also embedded in the ACI platform. So when people want to reduce their developer friction, various friction points are listed here. Ignore the ones they are self-correlating. Let's look at the numbers that are closer to 1, right? So the closest is build friction. The build durations are beyond the threshold, so that's the friction. Let's look at the next closest one, which is the block pipeline friction. So if you look at this and trace this, and look at the closest number to 1, and we see this, and that is blocked by flaky tests, right? If you trace that and look for the number closest to 1, you see test friction, do the same. It ends up at like integration tests. So this particular group has like a lot of like flaky integration tests, and that's what like the group needs to be prioritizing to address. And the same level of view is available for various groups, teams, and also at an application level. So people can understand the bottlenecks very quickly. Now here, you see a view where you can expand each friction points and then see an application scatter plot. And there's also AI-based like recommendation for which application should be prioritized in order to reduce developer friction for a given team. So it uses frictions, the number of commits, and the criticality of applications and various other features to recommend this. Next, we are at an application level. So here, if you look at this, it shows the pull requests, right, like that encountered friction. And it also recommended by an AI-generated recommendations. So here, what was happening was the build has been retried multiple times consistently, and then there's like failures on the test area. So the classification was done here as non-infrastructure related failure, and AI recommends fixing the test. And also, it is able to relate to another friction that would improve once retrays are removed here and tests are like solid. So and that is like merge to build duration friction. Builds are faster than merge to build. It's going to become faster as well. So here, the screen that you're looking at is a screenshot from our IDP, like showing the pipelines. And so this pipeline has failed in a feature-pull deployment phase, and there is an AI analysis of the failure, right? This is an RCA from AI, and our agent basically says that, okay, the application identifies the pod, the cluster where the failure occurred, and the reason, right? The reason for this is an unsatisfied bean dependency, and it recommends like solutions as well. And there's also like and dislike buttons with the RCA component, because it's very important whenever we use the agent to provide some information across our IDP, like it's important to capture how our developers like or dislike it, right? If they click on dislike, we ask for like more reasons, so we take that feedback and constantly improve the agents. And to the bottom right of the screen, you can see that there is an AI support widget. So clicking that will launch a chat window right on the platform where people can ask any questions about their applications or pipelines. So let's see how that looks. So there are a few examples here, right? So in the first example, the question is, what are the top failure reasons for my application, right? So it can analyze the historical data. So there are various tools. We'll look at that in a few slides. So there's various APIs integrated as tool calls for this agent. It accesses the appropriate APIs and then brings all the failure reasons and lists them down. And the next one is, the task here is to take a look at the historical data from the last 30 days and tell me if my pipeline has improved in speed. So here you can see the response from the agent, which says the success rate. It looked at the success rate, it looked at the duration, plotted a trend, and basically you can see that it says that the average duration has improved and the pipeline has been getting better. The last one is, how do I make my pipeline fast? So here, the agent looks at the pipeline definition, the historical runs, configuration across various phases, and suggests like optimizations. So here, you can see that one of the optimizations that's suggested was to go for a more aggressive deployment strategy. So there's a canary deployment strategy applied here, and it's suggesting like a more aggressive strategy. And it says that it's going to be a 20 minutes of saving if they adopt the strategy. And it doesn't do it recklessly, so the agent does has access to the historical deployment failures and all of that. So it takes a look at that, uses the historical data to make the recommendation. And there's another recommendation here, which is to parallelize some of the tasks in the pipeline itself, right? So some of the tasks in this pipeline were sequential, so it basically looked at that. There's no dependencies, so you can safely parallelize these tasks without breaking the integrity of the pipeline itself. And there's a button there in the response where people can click that. They can see the before and after of the recommendations and review that and then accept it. A click of a button, the changes are also made in the pipeline. So next, here's a screenshot of a Slack conversation. So the image to the left is about like RAG-based response. So here, user asks a question, and basically the LLM is able to leverage what we have in our vector databases and provide an answer from the documentations and also provide links for references. And to the right, it's basically using a tool call, and the task is to look at a pipeline and help them understand the failure. So it went, looked at the pipeline data and the pipeline run details, and then went through the logs and found the application startup failure and recommends a fix for that. So here's a example where you can see that this was a test failure, and the RCA was done in Slack. They were using a shared utility, and this failed because there was a 500 from one of the service. And they looked at the logs, and it found that there was a service that was marked down, and doesn't stop there. It goes to the downstream services, looks at the logs there, and found that no issues there, and finally gave its conclusion. So with that, let's look at an overview of one of the agents, right? Like, so this is an agent that we call internally as ECDX agent, and to the left you see the blue boxes, and these are various entry points, right? Like one of the things that we saw was in the pipeline there was an AI-based RCA. So it's that entry point. Second one was there was a support widget, clicking which people can chat with it. So this is that entry point. The last one is on the Slack, and people can chat with it. So this agent handles like two different modes, right? One is an RCA flow, and the second one is a chat flow. And it has access to a tool ecosystem. So the pipeline data, the definition of the pipeline, so pipeline run data, historical data, everything is like available as tool calls. And also it can get like logs from our pod clients. And then there are CD events and cloud events. All of these things are present to be accessible as well for the agent. Then there are like external agents like test result analyzer, dependency analyzer agents. And again, the important thing is the platform maintenance data too. Any ongoing issues that might be impacting pipelines on the platform, that's an important one as well. So this needs to be live, so that's the reason why this is not in the RAG, but it is a tool call. Next, deployment server analysis agent is another thing that has access to, and there are various other APIs that are integrated as tool calls for this agent. And you can see at the bottom, there is a rack store, so for the similarity index. And all our platform documentations, best practices, everything is in the vector DB. And the past support resolutions, these are also like important data that we store in our vector database. And then there is the agent accesses a central LLM gateway, which has access to multiple models. And there's not so most of our agents don't use a single model approach. And there are like multiple models that we use, like, get the response from one, like, get the confidence score, ask another one to review and things like that. So if you look at the RCA flow, it starts with the pipeline run ID. So it takes the pipeline run ID, and then for anything that is deterministic, we don't make an LLM call, right? So anything that is deterministic, we have a deterministic error processor that handles it, gives the reasons quickly. And if there are like service dependency issues, then it goes to the service dependency agent. Deployment failures, we leverage the deployment server log agents. And test failures, there's a test results analyzer for that. This takes care of analyzing the root cause for failures. If it is an UI-based test and it goes all the way to the services, then going through the dependencies and getting the root cause is important. On the chat flow, the first thing is like clarify and classify the questions, so that and this is all like handled with like dynamic prompting, and it retrieves the context and then gets the answer from the LLM. And once we have the answer, like it also like it reformats and injects UI visuals that you saw earlier in the examples. So this is how a quick overview of one of our agent. All right, results. So what have we gotten so far? Like 20 minutes of pipeline run that was saved, and this is across like 500 applications. Predictive optimizations helped us to go from commit to production in 45 minutes. So we were able to reduce our human-handled support requests by 15%. It brings focus on flow for our developers. And our AI-based code review agent has like 40% acceptance rate, and it contributed to reducing our production bugs by 10%. So the machine learning-based retries helps reduce context switching for our developers and increase the first run success rate by 6%. We see an RCA acceptance rate of 80%. Reducing saving several hundreds of developer hours in this case. And overall, we were able to reduce the developer friction by 1/3 in 6 months. So learnings-wise, the leadership and AI culture, strong executive sponsorship was a key for us to make some improvements, so that's very important. So most of the focus on the inner loop, but here we decided to focus on the outer loop to reduce the lead time for change, so that really helped. And upskilling, training engineers across the platform engineering group was a key aspect as well. So iterative development, starting small with safe prototypes, putting the right guardrails in place, very important. And rapid cycles, expect failures, learn fast, improve the agents quickly. So again, feedback and evaluation is very important, right? So anytime there's an AI-based response that goes in, embedding real-time feedback where thumbs up, thumbs down, also correction logs, through the chat is also important. And model evals for every use case is an important aspect, so that when we experiment with different models, we can see if there's any regression or improvements. So interoperability within existing tools is very important. We love CD events, helps us a lot. And that way we can get structured and relevant context information back to the LLMs. And we make a conscious decision to use LLM to reduce wherever we can reduce toil or adds intelligence to the decision-making process. And rules-based automation is what we use for deterministic tasks. Of course, data is everything, right? So in making sure that the relevant context and information is present in the vector database is very important. So docs, logs, support threads, all of that. And live events are from CI/CD events and maintenance events. So the next thing is dynamic prompting. So assembling prompts based on the tool state and user context and history is very important. And finally, there's no one size that fits all. Choosing the right models and AI solutions based on the workflow and the goals, that's a key aspect of this journey. So next, where we're going towards is a pipeline factory agent. This is to automatically generate tasks, and we use Tekton underneath. So this is to automatically generate Tekton tasks using a generate test fix loop. So the goal is to reduce the barrier for entry. so that various stakeholders across the platform engineering groups and like our application groups are able to contribute Tecton tasks. And next is like personalizations. One example is with our AI code reviewer tool. So we want this agent to learn from the experts within each team so that it can balance the nits versus critical issues and actually speak the same language as the team. So that's another area we're working on. Next. Right. Thank you.
All right. Thank you very much.